Rahul, can you see the screen? Yes, Pujita, right. Yes, Lavanya. Now, listen. We were discussing regarding the analysis of pinjointed perfect frames. In the analysis of pinjointed perfect frames, we studied about method of joints, method of sections, and one of the another method is method of tension coefficients. So, in the method of tension coefficients, we are going to analyze pin-jointed perfect frames. We are going to analyze pin-jointed perfect frames. This method was developed by Southwell, and this is applicable for plane, that is two-dimensional, as well as three-dimensional frames. And contemporarily, this method was also developed by Muller-Bressler independently. Southwell as well as Muller-Bressler were the inventors of this method of tension coefficients. What actually is there in this method? Here, just we considered a member AB in a three-dimensional space. You just understand here, when a member is there in a three-dimensional space, we can give the coordinates for that one. Coordinates are nothing but x, y, and z with respect to origin. If you consider origin is this one is origin. From this origin, we can obtain what is the coordinates of member. That is A point as well as B point. So something like I am giving from x-axis it is xa, y-axis ya, z-axis za. Similarly, xb, yb, and zb is the coordinate axis for B. What we are going to do here in this method, every member will be assumed to be in tension. That's why the method name is given as tension coefficient method. We will assume all the forces in the members are in tension. Then the tension force can be expressed in any member is nothing but small tab into A. Small tab we call it as tension coefficient. Length of member AB is to be calculated. We'll see that one. Now, here at every joint, we will write down the equilibrium equations. Just these points we discussed in the last class. That's why I am just moving with a slight early. You can once again, the recorded videos will be uploaded in the YouTube. First video I uploaded today. The remaining videos I will upload within a short time. I have to edit it. The video, that means the video channel will be shared to you. You can subscribe it, or otherwise you can just listen the classes. These are purely for our students. These are purely for our students. I am unable to get my channel here. Can anyone of you just type it in Google or in YouTube? Just type it as with this name. I am typing in the chat box. So just copy and paste in the YouTube. You will get the first link that will be there for the recorded classes. Those who are unable to get the proper signal, the recorded classes you can listen and follow it regularly. For the sake of our students only, this is done. So what we have done, we have written the equilibrium equations at the joint. Now consider here, a joint is there where three members are meeting. Three members are AB, AC, and AD. The length of each member is LAB, LAC, LAD. Now, the equation of equilibrium along x direction will be written like this: xb minus xa into dba plus xc minus xa into dca plus xd minus xa into tda plus xa. Capital xa is nothing but external force acting along x direction. Similarly, along y, along z, the equilibrium equations will be written. Now, after obtaining these equilibrium equations, we are getting length of the members. The length of the member in your simple mathematics, you studied this. The length of the member, if it is in a space, we can calculate using this equation. Is in between b and a, so xb minus xa whole square plus yb minus ya whole square plus zb minus za whole square. Similarly, length of member LCA and LA is calculated. Here there are three equations are available along x, y and z directions. The three unknowns are there. The tension coefficients, the three unknowns are there for the members. These tension coefficients can be calculated using this equation. Then the forces, final forces in the members can be calculated. That is TBA into LBA. Tension force in CA is TCA into LCA, where this TCA is tension coefficient, capital TCA is tension force. Now, if it is positive, that is tension. If it is negative, that is compression. Simple sign convention we can follow. Now, after that, we have observed what is the procedure that is followed in this tension coefficient method. First one is identify the x, y, and z axis positive directions. Assume all the members are in tension. Write down the equilibrium equations at each joint and solve the equations for tension coefficients. Then finally calculate the tension force. That's it. I asked you people to solve this problem. We have done this, which is in a space dimension, x, y, and z direction. Now, note down one problem we'll solve, and those who missed the class, we can once again follow it. Once again, we can follow it. Okay, so please note down the question. Determine the forces in the space frame members. Determine the forces in space frame members. Point D is 4.5 meters above the horizontal plane. 4.5 meters above the horizontal plane. Now, just note on the diagram. The distances are given here. I am giving you the distances. So these are the distances given. It is given that A, B, C are at the same level. Point D is 4.5 meters above the horizontal plane. 4.5 meters above the horizontal plane. Just assume a tripod. Your surveying equipment, so you have seen a tripod. It looks like this. A tripod. This is point A, B, and C. They are at the ground level or at the same level. Now the point D is at a height of 4.5 meters above the ground level. What is the first step that is followed as per this method of tension coefficient? First, represent the x, y, and z axis. So here I am representing, just you can take any point as an origin. Any joint can be considered as an origin. I am just taking this bottom one as the origin. Joint B will be considered as the origin. And the positive x-axis will be towards right side. Positive y-axis will be like this. It is given in the question that a point load of 100 kilonewtons is acting at D, and at 150 here this is also acting 150 kilonewtons. Now, just if this is x-axis, if this is y-axis, our z-axis will be vertically in the upward direction. This is our z-axis. So what we are doing here, we denoted x, y, and z axis considering B is the origin. Joint B is considered as origin. Now prepare a tabular form. Point A, B, sorry, it will be correction here. X, Y, Z. How many points are there here? 4 points are there. A, B, C, and D. Now, we are considering origin is B, so hence origin this will become 0, 0, 0. Wherever you are considering that will be considered as origin. Now, what is the coordinates of A? Coordinates of A. Here along x direction this point is 0, but along y direction this is 5. So 0, 5, and along z axis it is 0. So 0, 5, 0. You get my point or not? Here, just see once again. We are first representing the origin, and the origin, yes, you can represent the origin at C, at D, at A, anywhere, but the coordinates will be changed with respect to the origin. What is the other point? What is the other point? With respect to the origin, what is the other point? Here, with respect to B, A is 0, 5, 0. How? And along x-axis it is 0, along y-axis 5, along z-axis it is in the same plane, that's why 0. Thus coming to C, can any one of you tell me what is the coordinates of C? What is the coordinate of C? You can type in the chat box. Yes, you will respond it. The coordinates of this one are 4.5, 2.5, 4.5. Now you got the coordinates. Initially, first fix the origin and give the positive axis, and then you represent what are the points, what are the coordinates of A, B, C, and D. Now afterwards, consider a joint. Where is the joint? Here D is the joint which is meeting, which is like along x-axis we are writing the equations of equilibrium. What is the equation we have to write along x-axis? Here for the members, how many members are there here? AD, ED, C. Now along x-axis means the coordinates XA minus XD into DED. So tension coefficient multiplied with the coordinates, the difference between the coordinates along x-axis plus XB minus XD into DBD, XC minus XD into DCD plus capital XD is equal to 0. Remember, we are writing the equilibrium equations at a joint D. At joint D. So here, just understand here at the joint D, Is there any point load along x-axis? Yes, there is a point load. So XB you have to write down it as 150 kilonewtons. But what is the sign convention? You assumed your positive x-axis towards in this direction, but the point load is acting opposite to h. So for your assumption, it is opposite. So keep it as similarly, YD at D, along y direction, 100 kilonewtons load is there, but it is opposite to the assumed direction, minus 100 kilonewtons. Substitute the values here in the equation. XA is 0, minus 4.5 into DAD, plus XB is 0, minus 4.5 into DBD, plus 7.5 minus 4.5. Just substitute the coordinates that you got along x direction. XA, XB, XC, XD. That's it. Into DCD. This is minus 150 is equal to 0. Simplify this equation. This is minus 4.5 into EAD, minus 4.5 into TBD, plus 3 into ECD is equal to 150. Keep it as equation number 1. Keep it as equation number 1. Now along y-axis, just simply that is TAD will be there, but this will be YA minus YD plus YB minus YD TBD plus YC minus YD into TCD plus YD is equal to 0. What are the coordinates of YA? 5 minus 5 minus 2.5 into TAD, 0 minus 2.5 into TBD plus YC minus YD. What is the value of YC? 2.5 minus 2.5 minus 2.5 into TCD plus YD. YD is nothing but external force. The value of external force we got is minus 100. So substitute with minus 100 equal to 0. Now simplify this one. 2.5 into minus 2.5 into plus 0 into TCD is equal to 100. Now write down along z-axis. Simply this ZA minus ZD into DAD plus ZB minus ZD into TBD, ZC minus ZD into DCD plus ZD is equal to 0. That is along the height, along the height. So the coordinates here, this is 0 minus 4.5 DAD. How you got ZA? We already represented the coordinates for point A, where Z is 0 for A, B, C. Only D is having 4.5 meters height on the bottom plane. So that's why this is 0 minus 4.5 into TBD, 0 minus 4.5 into TCD. Now, in the question, there is no force along Z direction, hence plus 0 is equal to 0. This is minus 4.5 into TAD, minus 4.5 into TBD, minus 4.5 into TCD, equal to 0. 3. Solving equations 1 and 2 and 3. 1 and 3. Using your calculator, you can solve the 3 equations and tell me the values of the coefficients. Coefficients are nothing but AD, TBD, TCD. So you got these TAD, TBD, TCD values. Calculate the length of the members. LAD is equal to square root of, just if you want to know the length of the member in space, XA minus XD whole square plus YA minus YD whole square plus ZA minus ZD whole square. In terms of meters, you will get the length of the member. Similarly, LBD also. XB minus XD whole square plus YB minus YD whole square plus ZB minus ZD whole square. Similarly, LCD, square root of XC minus XD whole square plus YC minus YD whole square plus ZC minus ZD whole square. And tell me the answers also on this. So then you can get the tension, you can get the forces. Capital TAD is nothing but tension coefficient small TAD into LAD. LTBD is equal to capital small TBD into LBD. That is nothing but tension coefficient multiplied with the length of the member. LCD is nothing but small TCD into LCD. So you just post the answers for the length of the members as well as tension, the forces. PD is under compression. So the answers are here. So these are the answers. TAD is under tension. This is under compression. This is under tension. So this is how we solve the problem. I'm just giving you one problem. If you can try, if you are able to solve it, just try it. Determine the forces in the given. Determine the forces in the given Warren type cantilever truss using method of joints. I'm not saying you to do as per method of section, method of tension coefficients. Please do this problem using method of joints. And we will check these answers with the method of tension coefficient later. Whatever the method you are following, but the answers should be the same. Here 2 kilonewtons vertical load is acting. This is 8 meters. This is 8 meters. Distance is also 8 meters. The angle here it is 60. This is 60. These all are equilateral triangles. A point of 2 kilonewtons is acting here. 3 kilonewtons is acting here. And also 3 kilonewtons load is acting here. This distance is 4 meters. Okay. So using method of joints, please try to solve this problem and show me the final result. show you what is the final result. Yes, I have noted down the attendance. You people can leave the class and after solving this, can send me the answers.